Hello, everyone, and welcome to the 7th Angular Belgrade Meetup. For today, we have two talks by our guests, Brandon Roberts and Jordan Powell. The first talk for today is about new meta framework for building Angular applications and websites called Analog by Brandon Roberts. Brandon is a developer advocate at Upright, a Google developer expert in Angular, and maintainer of NgRx and Analog projects. Welcome, Brandon, and thank you very much for accepting my invitation to join us today.
Hey, and thanks for having me, and thanks for the intro. I'm gonna do the intro over again, but it's okay. But
Yeah,
thanks for having me.
it's my pleasure. Okay, if you're ready, the stage is yours.
Cool.
I will just add. Great.
Yeah. So, name of this talk is bringing Vite to Angular with Analog. And if you've seen me on Twitter, you probably seen me shouting about this for a while now. But it's good to give a talk about this at the Angular Belgrade meetup. So, with that, you've seen me around on Twitter, Brandon T. Roberts. You can follow me there. As Marco mentioned, I'm a maintainer on the NgRx project, also a Google developer expert in Angular, which just means I've been around the community for a while. I've been doing some things there, and also a developer advocate slash DX engineer at Upright. And Upright is another open source project. So as you can see, I'm all about the open source. So for this talk, I want to cover a few main topics here. I want to talk about Vite and kind of cover the story around that, talk about meta frameworks and what those look like today, what kind of features they have, and also talk about analog, which is something that I am really excited about and am working on to help push Angular forward in a way. So first, let's get into the story about Vite and how we even got here, how we are moving in this direction. So first, I'll talk about the backstory of Vite and like the author, and get into some of the features of Vite, and then the impact that it has had on the web and kind of where we're going. So for the backstory, I want to talk about the creator of Vite because his story is pretty interesting, I think, in some regards, and also some of the problems that Vite intends to solve. So if you've seen the creator of Vite, most likely his name is Evan Yu, and he created Vue.js, and but you maybe a lesser known fact is that Evan Yu also used to be involved in the AngularJS ecosystem, which is why some of the parts of Vue.js probably look and feel similar in that way. As I mentioned, he also was in AngularJS, and he also, like I said, went on to create Vite. And yes, I say Vite. I've heard other people say it different ways, but Vite is what I understand from the doc, so we're going to go with that. Yeah, so some of the problems that Vite intends to solve, and a lot of these are mainly around development, but slow server starts. Some of the problems that Vite intends to solve this way is they want the development experience to be fast. So you don't want to have to take a long time when you start your command to run the app before it starts up. And also, just using a different approach as opposed to bundle-based development where it dynamically loads files using browser APIs. And we've had many different takes on support for like ES modules, but this has become more important in development and also integrates in with Vite. But overall, it wants to improve the developer experience for building front-end applications. We want that to be fast and enjoyable to work with. So those are some of the main problems that Vite intends to solve. So some of the features to go along with that Vite tackles directly is instant server start. Like I said, it dynamically loads modules when you need them, as opposed to bundling up your entire app. and this gives you some benefits there. Also has integration for HMR or hot module replacement. That way you get that nice quick refresh when you're making changes to like CSS or things that are like inline in the application. And it definitely focuses on developer experience out of the box. So you, like I said, you get the speed improvements and you're able to develop faster and enjoy that experience there. Of course, we all want fast builds. So it, we'll talk about how those work more, how Vite works more as far as transforming files, extensibility of plugins, to, like I said, allow extension through other ecosystems, and TypeScript support out of the box. So it doesn't do type checking, but TypeScript out of the box allows us to have that nice experience of developing TypeScript, because we're all familiar with that in the Angular ecosystem. So naturally, everyone in Angular just wants this in some form or another. We want all these bells and whistles just like everyone else has, and we want to keep that rolling. So next we'll talk about the impact that kind of Vite has had on the web ecosystem. And before we get into that, I do want to talk about where we are today, because there were bundlers before Vite, and of course there will be bundlers or systems after Vite. But today, Angular uses Webpack under the hood, and it is a bundler. And Webpack uses more of a bundle-based approach, and it has loaders also and plugins to extend how you can extend the usage of Webpack and kind of integrate in with this system. And of course, the biggest thing these days is module federation. So there's definitely a lot of infrastructure out there already that takes advantage of Webpack and the features that it provides. And I've also seen that in some places Vite wasn't intended to take over the usage of Webpack, but it just seems that the web has kind of moved in that way. So if we, like I said, looking at the web landscape today, there's definitely been a shift in mass to adopt Vite. If we look at projects like Astro or their integrations for React, so you get that nice experience there. If we look at Solid.js, and some of these may be familiar to you, some may be new, Nuxt, Vue.js, of course, it has very great integration there. Svelte, Quick, and also in things like Playwright and Vitest, which is also built on top of Vite. And there's also more, of course, more projects here that I haven't listed that integrate in with Vite. So as you can see, we've already like landed on that. So next, let's talk about meta frameworks. And we'll talk about the definition of what a meta framework is and some of the common features that are associated with meta frameworks. So a meta framework is defined as a system that is one level above that stitches multiple frameworks together. And I got that quote there from Ben Holmes. I'll link to the Prismic blog there, so you can definitely check that blog out. It's very good there. And of course, Angular is a framework on its own, because it has its own core of components, pipes, directives, and services. We have routing, HTTP client, forms, SSR, and even more. So Angular itself already is already a framework that provides all of these things out of the box. So there are, of course, in other ecosystems, there are meta frameworks like Next.js that build on top of React. There's SvelteKit that builds on top of Svelte. Remix is another React framework, meta framework. Astro, which is another project that I'm really excited about, that kind of builds on top of around all of these kind of frameworks that lets you integrate with those. In the Vue ecosystem, there's Nuxt, Solid Start, and there's also Quick City. So some of these meta framework features that we commonly see is features like file-based routing, to where, and we'll talk about more of that in a second. server-side rendering, where it's kind of well integrated there, static site generation, and API routes, where you can define those routes on your own that are not bundled with your server or application code. So with file-based routing, what we normally think about when we configure Angular routes is you have a routes file, you wire up your paths and your components or your child routes, and you have this all as part of your code base. With file-based routing, this is more defined by convention, to where your routes are defined in folders, and we can traverse those folders and files and create this route config or route tree for you. So it's a little less, one thing that you can use by convention to configure those routes, which is pretty nice. There's also server-side rendering, as I mentioned, where the application is actually rendered on the server. The HTML is shipped to the client, and the application is then hydrated on the client. And our most common use case for this today is Angular Universal, which comes as sort of like a separate package that you have to add onto your Angular application. There's also static site generation. This is mostly content-focused websites. If you have like landing pages, marketing sites, blogs, and more. And today we usually use Scully for these type of sites if you want to build these with Angular. There's also I don't want to say it's new, but relatively new architecture of the Islands architecture that uses partial hydration to build entire websites, where this is like an alternative to a single JS bundle, where the pieces of your application are loaded in isolation by default and don't have knowledge of each other. And you can use this to use this architecture to render different pieces of your application. So if we look at this example page here, it has some distinct areas. We have a header that can be loaded independently on its own island, navigation bar, and a content area. So these things could be, like I said, loaded on their own using the islands architecture. And also, we can also render these pages on the server and then hydrate them as needed. So with API routes, this allows you to build APIs without external libraries, very convention based. As we mentioned with file-based routing, you can define these routes inline in your component. In a framework like Remix, they have things like actions and loaders that are there. In Next.js, we have examples like get static props. So it leads us all the way up to, and Angular has, like I said, traditionally been in a place where we're kind of off doing our own thing, but we want in on the fun, right? We looked at the kind of like where the landscape of the web is, and we definitely want Angular to be included in that future, like I said, of Vite and these other build tools that help improve the developer experience. So that's where Analog comes in. Now, Analog, as I mentioned before, is a meta framework that's a combination of things that are combining multiple frameworks together. And like I said, I linked to that post by Ben Holmes on the Prismic blog, so you can definitely check that out. And Analog is a meta framework for building applications and website using Angular. And we got a nice logo there. Was props to Marco and Tim and other people who helped me with the logo there. So, but I know what you're thinking. Why are we doing this now? Why put the effort into putting this meta framework together when Angular is already a framework itself? So I've been kind of thinking about this for a while. So it's not just something that I intentionally, or something that I just kind of came up with overnight. So, but the thing about it is ideas are great, but like executing and putting those ideas into place does take time, and it takes other things to happen for something like this to come into place. And some things have changed since then. In the Angular ecosystem, we've gotten standalone components, which were landed in Angular v14 and have continued to be developed there and have opened up a lot of possibilities with Angular, including using Angular components in other ecosystems. There's been the development, the Angular team has been experimenting with an ES-Build based browser builder. And this is also what Vite uses under the hood in optimizing dependencies for building apps. So there's already some crossover there, and we've also had some interesting pains with ESM in the ecosystem, but this has also helped with the Vite integration also. So some of these things, like I said, have happened over time to help move this particular thing forward. So let's talk about how Angular compilation works today, because this ties into the where we are today with the Vite and Angular story. So Angular wraps the Angular compiler wraps TypeScript to provide Angular specific metadata, and this happens in a global way of like it needs to know all your source files, how those things are wired together, and then it can use those files to produce an output of that particular bundle of those particular files. Taking a look at the Vite transform pipeline, works a bit differently. As we mentioned before, there's Vite, and then we have these separate files who it can uses a single file compilation. So it can transform and process these files in parallel, along with loading these files on demand and loading these things in parallel. It can produce these outputs a lot faster, which, like I said, in turn speeds up development there. So the Angular, one good thing about this is that the Angular team is also thinking about this potential also. As mentioned with the ES-Build browser, we could get to a place based on where that goes, we could end up with Angular compilation having some form of single file compilation. And like I said, these things kind of build into the story of where we are today with Angular compilation, with standalone components. All these things kind of fit into that story. So we could get to a place to where Angular could have single file compilation and fit right into this ES-Build Vite story and speed up that development there. So analog itself, of course, we went to, this is all powered by Vite, and we wanted to take advantage of the things that Vite has to offer, like I said, just as other ecosystems have. So the things that we want to take advantage of, like I said, fast development. We want to be able to develop these apps faster, take advantage of the plugin ecosystem that Vite provides, and that in turn builds on top of Rollup. So there's already an existing ecosystem there, and this also aligns Angular more with kind of like we said, where the web is going as far as tools go, and having that integration and be able to take advantage of that evolving ecosystem is nice. There's also Vitest, which is built on top of Vite, and this is part of what Analog provides also. It's powered by Vite. It's also jest compatible, so you get a similar API, a smart watch mode where it only transforms files that are needed, and another thing, ESM and TypeScript support out of the box, which is there. So some of the Angular analog features that we can take advantage of today, because we're still in active development, of course. And of course, we're powered by Vite. We're using Vitest, unit testing with Vitest, and also some integrations there in different projects, such as Astro, which is one I mentioned before, which is a static site generator. And I wrote a blog post. You can definitely check that out about using Angular components inside Astro projects. Storybook is another project that is investing in Vite, and we could also take advantage of the Vite plugin for Angular inside the analog project there. And also Playwright. They have some integration with Vite, and like I said, all these things are going to build on top of that, and I'm sure there'll be more integrations we can provide in the future. So some of the future features coming to analog that we're looking at building are file-based routing, as I mentioned before, making it easier to onboard with building Angular apps and routing conventions, having server-side rendering and static site generation kind of integrated into the platform itself. So it just feels more integrated and well put together. And another thing is server API routes. And this is where you can, if you only have a few routes, you can talk to your database directly in these routes and have that integrated experience with building applications with Angular. And if you want to, of course, reach out to other APIs, you can do that also. And more integrations, like I mentioned, Astro and some of the others, and being able to integrate with these other systems. We'll look at providing other ways to do that also. So, of course, contributing to a project, it definitely helps to the health and sustainability. And we're always looking for contributions, whether it be GitHub issues, documentation. We have a site up at analogjs.org. You can check that out. Pull requests, like I said, are always welcome. And sponsorships are always welcome too, because, of course, open source project, we're doing this as a part of our free time and things there. So it will help with some of those things there. Hey, we have a wonderful set of contributors here, and definitely would like to add some more people to the project. So definitely, if you want to get involved, you can go to the GitHub repo at github.com/analogjs/analog, or like I said, go to analogjs.org to see that. So yeah, to recap, I talked about Vite and like the backstory of Vite. I talked about meta frameworks, the features that they offer, and also talked about analog there and how it integrates, like I said, within the web ecosystem, and how we want to move forward with that. And I will show a quick demo here of analog. So stop my screen share. I'll share my window here. So we have a pretty standard Angular project. We just have an app component. I've saved you the time of downloading npm dependencies on stream here. And we already have the Vite project running. So I'll stop that. I'll run yarn dev, and it spins up Vite really quickly. And we can see that the application runs here. And like I said, this is just a sample app. We're doing some clicking around here to see the app component. But like I said, the idea is that you still build your Angular application the same way, same structure that you would normally have, but we're just powering, using Vite and then adding these additional things on top of that to make that experience faster. And we'll make a change here, Angular Belgrade, and it, updated before I even got to the tab there, which is pretty nice, even for a small app. So yeah, so that is it for my talk. Thank you for opportunity, and like I said, looking forward to more contributions.
Great presentation, Brendan, as always. Thank you very much.
Thanks.
I have one question for you because I tried something and didn't succeed. So is currently possible to use Vite Angular plugin with Angular project that uses SCSS for styles?
SCSS for styles. I think you have to do it a little maybe have to do it a little differently, where you have to like import. This is one of the things that we can look at. But Vite supports like importing uh, SAS files directly, and then you can drop that into the styles array because it will give you the output back from that. So I believe that's one way to work around that. But I know it works with vanilla CSS today, and that could be something that we'll look at in the future.
Nice. And regarding API route, what will Analog use as a server engine?
Yeah, so right now I've been looking at a project called Nitro, which is the same engine that powers Nuxt underneath, but it's framework agnostic, so you could use it and it integrates in with Vite also. So that's one of the options I was looking at. If we're looking at something that's like already out there, or if we're looking at maybe another option of building something internal to Analog. But Nitro is a pretty cool project, and it has a lot of development done there already. And I think it kind of fits in to what I think the vision for like server API routes is. So if not that, like I said, then we'll look at maybe doing a design on what we want to do if we want to do something different there.
Cool. Okay, it seems there are no questions in the chat. Jordan, do you maybe have some question for Brandon?
Oh, I have a lot of questions. No, nothing that really sticks out up front. My question, the thing I was thinking about was testing, like, is how what type of support, like currently does it support like just Karma out of the box, or like what type of testing is supported at the moment?
Yeah, for a good question. Yeah, for unit testing, it supports vtest out of the box. And if you want to integrate, as far as that's for unit testing, it doesn't prescribe anything out of the box for end-to-end testing, but you could definitely use Cypress or other tools if you choose to in that area. Because we do have some integration tests or EDE tests in the GitHub repo for Cypress and Playwright there. So you can kind of use that as maybe a reference.
Sweet.
Yeah, I got it. Maybe that leads to another question. Is the Cypress team working on integration with Vite somehow?
I think it's definitely. I've seen some conversations around this. I don't have any deadlines or promises, but it's something we're thinking about for sure. So
cool.
Great. Okay, if there are no more questions, we can move to the next topic for today. Thanks again, Brandon.
Thank you.
So the next talk for today is Angular component testing in Cypress by Jordan Powell, who is developer experience engineer at Cypress. Welcome again, Jordan, and thank you so much for joining us today.
Thank you. Let me go ahead and share my screen. Perfect. Awesome. Thank you for having me, Marco, and thank you for being I was talking with Mike Ryan at NGConf about how every time I go to the NgRx repo, I feel like there's no work to be done. Like it feels like it's a pretty mature product, and then it's like every month I feel like you just put out like some new feature for NgRx that I'm like, oh yeah, I should have thought of that. So thank you for all you've done over there, and then also congratulations on becoming an official like core team member at NgRx. So, but anyways,
so much.
Yes, onto my talk. So today I'm going to talk about component testing with Angular, focused with Cypress, primarily going to focus on Angular being it's my favorite framework, and this is an Angular meetup. So this is a feature component testing that we released back in June with 10.0 of Cypress, and we added support for Angular in 10.5. All right, a little bit about me. like Marco said, my name is Jordan Powell. I'm a developer experience engineer at Cypress. And you can reach out to me on the Twitters, GitHub, and so forth at Jordan Powell 88. And I have a blog at jordanpowell88.com. So today I'm going to just do a quick why Cypress component testing, and then a demo and answer any questions you have. The reason why I wanted to start with why component testing is because when I joined Cypress and I heard about component testing, I was not sold. I'm like, what is this? I don't understand the problem it's like solving. And I was pretty pessimistic and not really like sure the main benefit. And then the more I began to use it and work with it, it sort of like began to click, and I began to realize like how powerful component testing could be. And the thing that really clicked for me is I really felt like Angular as a framework was probably one of the best use cases for it in a lot of ways. And so yeah, I'm excited to explain why you should use component testing. And because obviously I think there's like bazillions of decisions we make as engineers. And I think answering the why is always like really important, because if not, we'll just always be trying to adopt the newest thing and we'll never get anything done. So I think it's always important to answer the why. But for me, the first thing is that like why component testing? And the way I like to think about it is this way: is historically we used to build websites in this like notion of pages. So we would build a website from I need a home page, and I need an about page, and I need a services page, a product details page, so forth. And so we would write our code and build like our websites based upon this notion of like a page. And then eventually we realized that like it wasn't necessarily the best way, because a lot of websites had shared parts. And so we began to think of websites in the terms of our applications in terms of components. So instead of thinking about our sites like this, we began to think about them like this. And so what that means is that we really front end development has really taken what I like to call like a component driven development approach. And this happened sort of, I don't know if it was necessarily intentional, but these are some of the reasons why that we've kind of arrived here. And essentially, in my opinion, like the biggest reason is the acceleration, adoption of component driven development frameworks like Angular, React, Vue, Svelte, and so forth. And the idea is that those frameworks took a very component driven centric approach to development. And because of that, everyone else used those tools because it made problems that we all had previously much easier to solve. The other idea is that we build software differently, and so now we have autonomous teams, and we want to be able to be sure that the changes that I make on my team don't affect the changes on 10 other teams somewhere else. And so building sites from the context of a component versus an entire page or a bigger feature set, kind of, it helps protect that. Also, there's been this accelerated need for code that is scalable and decoupled. For obvious reasons, those things are important. We want to have scalable code, and we want code that's not coupled to everything around it, right? And so components really help enforce this behavior. We also have components help enforce reuse and consistency. And so when we have a component, we can use it consistently throughout our application, throughout other applications, and other types of things. So components really help provide consistent reuse across our application and multiple applications. And then ultimately improved maintainability, because who likes to build things and then have to maintain it over and over again constantly, right? So I certainly don't like to do that. So by isolating some of the features and putting things in components, it helps improve maintainability over time. Another reason why I like to say why component testing is valuable is because component testing provides documentation like out of the box. So when we began documenting the things that your components do, it provides the sense of documentation for what it does. And what I mean by that is when you do like typical, like we used to like in Angular, you would do like karma testing of a component, and you would essentially mostly do like unit testing of the methods um, in the class or something like that. Well, those things are great, and I'm all for unit testing. Definitely, component testing doesn't replace unit testing, but it doesn't really necessarily document the behaviors a user would take or would like the behaviors a user will like interact, how a user will interact with your component. There you go. It also provides confidence, right? Like testing, that's one of the like the biggest things is like you want to be able to sleep good at night. You want to be confident that when you make this change to the style, this change to this behavior of a button or a card or whatever your component is, that it doesn't break all the things that consume it, right? That's a really important thing. One of the things that's really specific to component testing is that you get it in isolation. And what I mean by that is that with end-to-end testing, which is also really important, and you really get like the most bang for your buck, but it really does it tests all the things kind of in relationship to each other. So it tests all the components work together, the integrations between them, the way they communicate, the way maybe your front end communicates with the back end, a database, so forth. But we don't really have an isolated way to test the components the way users do. And that's what component testing provides. And then ultimately, an improved user experience because our users are the things that use our applications, make our companies money, and gives us jobs, right? Those things are important. The other thing I wanted to talk about, quick highlight, is test-driven development. I have to admit, I'm not the biggest advocate of test-driven development. I think it's really great tool when you know the given out, like the expected output of a function, or when you know the results of something you're building before you start it. But there's a lot of cases where that's hard to define, and so sometimes we get too boxed into this idea of test driven development. But with component testing, I feel like it's really one of the best use cases for test driven development. And what I mean by that is that when you're mounting a component and testing it with Cypress, you get this instantaneous feedbacks right next to your test runner. So you see if I change a style, it automatically hot reloads, and you see the style changes directly in your test. If you change the behavior of the component, the way it interacts, maybe it sends an output to a child, to a parent component, or maybe something, it interacts with a child component or something like that. You can see all that behavior directly right inside of Cypress as you're building it. So you get this instantaneous feedback where the feedback loop becomes very, very short, and it makes it much quicker to test the things you care about. I remember I worked for a company once, and we did these flows. So we had like a user would start on page one, and you'd have to like fill like a series of maybe 3 forms to get to like a thank you page or something. And anytime I had to build something for that thank you page, I hated it because anytime I made a change to a style, any change to the logic, or any change at all, I would have to go through these like very articulate steps to get to the thing I actually cared about. Well, now with component testing, you could just mount that thank you component directly in Cypress and just test it in isolation, get it to where you want it, and then serve your app, test it out manually, see if it works. And then if you wanted to run an end-to-end test to validate all the steps, you could do that as well. So you really get this sort of natural TDD behavior when using component testing. And again, so instead of building components in serving up your app and then building the component and then seeing how it affects the app, your website directly, you sort of get this like, I only care about this box in the corner, so I'm only going to mount this component inside of Cypress and only focus on that. For someone, not only does it help narrow your focus, but it also keeps you from being distracted from other things on the page as well. Also helps just this nature of shifting left. And what I mean by that is we used to build software from this essential, this guide where we start with system requirements, then it would turn into software requirements that would turn into analysis, then program design. Once we had a program design, we begin coding, and then we'd be like, hey, we should probably test this before we like ship it out to all of our users. The idea is like shifting left is like we want to take testing instead of making it like the last thing we do and move it all the way to the left as far as possible so that we begin thinking of testing really from the very beginning and throughout every step of this process. So before I start doing a demo on component testing, I think it's important to understand what are the main differences between end-to-end and component testing. So here's a quick like chart that kind of shows the differences. So again, component testing does not replace end-to-end. It just changes the types of things that we test. So like what's tested with end-to-end, you're testing all of your app layer, the UI, your services, database, how they all interact together. You're testing that with end-to-end. Where component testing, you're testing individual components at a time. The characteristics of end-to-end is that they're more comprehensive, they're a little slower, more susceptible to flake because it depends upon everything working all at once, which is a valuable test to run. But any change to your application could cause it to break, which is a good thing because you want to catch those things. But sometimes when we only care about the minute specific things, those things can just be a hindrance to testing. With component testing, you get very specialized, quick, and reliable feedback. The other thing is they're written by end-to-end tests are written primarily by developers, QA teams, things like that. Whereas component testing, it's a little more. It's a little bit different persona. And what I mean by that is for QA, like when you run Cypress end-to-end testing in the browser, it basically runs on top of the compiled code in the browser. So it doesn't know what framework you're using. It doesn't know like any of the minutia details of how your application was implemented. It just says, hey, I'm just reading this DOM, reading the DOM, and I'm going to write test against it. Whereas component testing, it's very, those tests live actually next to the component. And so it's very framework specific. So you're going to typically find developers and designers, people that work closely with your framework, your front end components themselves are going to be the ones writing component testing. Not that a QA person, couldn't write them, but typically developers and designers are going to be the ones writing them. And then the other main thing I want to highlight is this last thing, and is that is the initialization command. And what I mean by that is the way you kick off or start a Cypress end-to-end test is through site@visit. And the idea is that you visit a URL, and that's the thing that says, hey, I'm ready to begin. You're saying, I need to first visit this URL and then I'm going to make some assertions and do some checks beyond that. Well, with component testing, there is like this no concept of routing, right? So I know Brandon's a huge, I joke with him at NgConf that I think he dreams about routing every day. He's always solving routing problems. But so sorry, Brandon, this isn't component testing has no reference, really, no idea of routing. The idea is that you're mounting a component to basically like an empty canvas. So instead of visiting a route, you're mounting a component. The other thing to think about is like what you test, right? So that's always the question we get is, okay, how do I know what to test? Well, for end-to-end testing, you're testing primarily user journeys. So why do you hate routing? I don't hate routers. Sorry. So you want to test journeys, right? So with end-to-end tests, you want to test the most critical things that your users do. So if you're some e-commerce website, you want to make sure users can search for a product, they can add it to their shopping cart, enter shipping information, payment information, and complete an order. That's a pretty vital, crucial part of your website. And if any one of those steps don't work, you're not gonna, your company is not gonna make money, and you're gonna get calls in the middle of the night. It's not gonna be happy. So with component testing, we don't want to think about it like that. We want to think about the individual components along the way. So the search bar, the shopping cart button, the shipping form, maybe the payment form, maybe an order summary component. You get the point. So let's get started. Let me show you how to get started with component testing. If you're not already using Cypress for end-to-end testing, you just use it doing npm install Cypress, and that will bring in the latest version of Cypress, and you can make that as a dev dependency. With 10.0, I mentioned we introduced component testing. So historically, we just had this idea of end-to-end testing. With 10.0, we basically created this idea we called unification, and it is basically we're taking both types of testing and putting it all inside of this one unified user experience. So if you already are using 10.0, you're already familiar with this. But in our case, we want to come, you see the little configured or not configured. We want to configure component testing. And for any of you who have migrated or haven't migrated to Cypress 10, I created a blog article kind of walking you through the steps and a video to kind of help any you along that journey. So let me do a quick demo, and hopefully this works good. Let's see. I need to share my screen, different screen, and whoops, 1 second. Okay, let me try it again. Share screen. Oops, wrong button. Okay, let me pull open this. Hopefully you can see this. Okay, so here is just a Angular application I created, and I installed Cypress, and I want to show you how to get started with this. Hopefully this will open up. Okay, you're not gonna be able to see my screen, but basically right now, component testing is not configured. I can show you by, let me see. I'm gonna have to switch screens a couple times here, Marco, sorry. But you can see it. Can you see it? Here we go. There we go. So you can see here, our app is not configured. So we're going to click component testing. It's going to recognize, hey, I see Angular is in your application. Do you want to pick that? If not, we have support for Create React app, Next React, Svelte, Vue, 2 and 3, and CLI, and all the different meta frameworks of Vue and React, essentially, plus Angular. And then just release support for Svelte as well. So click next steps. It will basically say, hey, check to make sure all the dependencies in your application are good to go. If not, it'll just say, hey, you need to install this one. We press continue. It's going to then tell us, hey, it's gonna generate these files for us. This is where our Cypress config. It's gonna tell us we're using Angular and Webpack. Hopefully, we'll be able to add Vite there, Brandon, in the future. And we're going to press continue. And let's see. Let me go and press start. And I'm going to have to, let me switch screen again. This is the hard part of Cypress, is there's so many windows for sharing. Okay, so if I go back here, we don't have any tests, right? So typically with end-to-end testing, you would put your tests like in an end-to-end folder in Cypress. But what we want to do with component testing is we want to put those tests directly next to the component. So this is just the very basic, default app we get when we scaffold out Angular. So let me go ahead and create an app.component.sci.ts file. And in 10.0, we changed from using .spec.ts to .sci.ts as the default spec pattern. You can change these, but because we want these Cypress component tests to live next to the component, we know you may also have like a Karma test or other type, maybe Jasmine or Jest, another type of test in those folders. So we created this .sci extension as the possibility. So if we go ahead and we want to say this is our app component and we want to make sure it can mount. Oops, if I can type. So we're going to use sci.mount, and then we're going to say app component. And if we save this, it will run, and you can see it's running. I have to keep going back and forth. But I'm going to show you a couple of different things we can do first, and then I'll switch back so you can see it in the browser. But with component testing, we use this mount function. It's just like a new function we expose. So you do sci.mount and then mount the component. And then you can also do it can mount using the template syntax. So this other is like how we're familiar with doing component testing or like testing a component using like Jasmine or Karma. But here you can also do this component. It should just be where's it at? It's just app root. So then we could just do how you would mount it app root like this. And the one thing is this will work, but it's going to cause an error. So when you mount this, it will actually not work correctly. And the reason why is the second argument of this mount function is a mount config. And the mount config basically has all of the test bed type things you're familiar with. So declarations, providers, any services that your component depends upon, and then maybe like any imports, things like that. And so by default, when you mount using this class syntax, we basically add app component by default. We push this to the declarations array under the covers. But when you use this template syntax, it's just a string. So we don't know the component you're mounting. So what you need to do when you use this template syntax is you can do something like this. And then this would work. The other idea is we also have component properties. So anything that's like a public property on this component. So like title, like if you see title, let me use this up here because this is a generic. So if I give this app component, this will work. So now if I do this, it's going to recognize, hey, this is a title, and I can pass it, whatever, hello. And it knows it's a string. You get typing. So it's going to tell you this is wrong. all those types of things. So you get component properties, so you have access to any public property or method inside of your mount, and then you get the ability to kind of just test things the way you always do it with Angular. But the one thing is, I'm going to show you a quick comparison. So this is basically a basic test, but it's the same thing as this, right? So if you compare these side by side, this is the exact same test. Or if I take this away, this is the exact same test. It's like 29 lines of code, and this is 7 lines of code. So you see, this is like significantly a better DX. And so then from here, the way you just go ahead and like you would click a button and then click it, and then you would do whatever like types of Cypress things you would do, and you would normally do. So you're using the same Cypress API you do for end-to-end testing, but you just mount it like this, and then you don't have to like do all this other stuff like you're used to doing. So let me go ahead and save this, and let me share my other screen quick just so you can see what it looks like. And hopefully, there we go. See that? So if I click here, you'll see here's our app. I'm telling it to get a button because I just did that, and there is no button on this page, so it's going to error. If I get rid of this, get rid of that and save it, it's going to then mount it. Here we go. So let's see. I messed it up. Live demos, right? So anyways, that's the gist of my talk from component testing. It's I'm excited for it. The main benefit is I was talking with someone at the NgConf, and they were talking about how they had all these Jest tests that were testing like their components using JS DOM, and there was a lot of things that they were like all these bugs that get introduced because it wasn't like a real DOM, right? It's a virtual DOM, and so the benefit of using component testing is like it's actually a browser you're running your test in, and you can like see exactly how they look, how they interact, and so forth. So
Thanks, Jordan. Great talk. I especially like the idea that designers should start writing tests.
yes,
I'll tell that to designers at my company. Yeah, we got a lot of questions. I will first highlight this idea from my friend Milos. He said Vite Angular plus Cypress to create AI generated tests.
That's interesting. I know you can Vite plugins allow you to generate files and things, so like on the fly. So I don't know about AI generated tests, but that I'm gonna punt on that one. I'll say that the Vite integration would probably support it, but I don't know much about doing the other part.
yeah. I mean, I think AI testing is something that's like going to come at some point. But yeah, I mean, it's like I want fast, and I don't want to have to do the work as well. Like, yeah, of course, we all sign up for that,
You mean someone's gonna write the test for me besides the designers? I don't. We'll have to see how that works out.
Okay. And the next question is component testing not unit testing?
So I would say the answer is no. I think that unit testing it still has a place. Like we still have functions that we like want to test. Like we want to validate that the code we write like works. But I would say like I like to say this like I think that component tests like we normally unit test our components to validate them. I think component testing really like eliminates any type of unit test you were doing in component testing. You can do a unit test of a method inside of a component, but I think really the thing is like we don't want to have a lot of like logic in our components to begin with, right? So it's like we really care that when our users interact with their component, like it behaves as expected. So it's like a higher level of testing, so I would say it doesn't replace unit testing, but in my opinion, it replaces unit testing of a component.
Yeah. And the next question is, were there any struggles involved with rendering the component in isolation?
Like along the way or like now? Yeah, definitely along the way it was difficult. But rendering and isolation is pretty simple. You just mount whatever component you want, and then it just shows there. Like, it's like pretty simple, and it's kind of like, oh yeah, like why haven't we been doing this a long time ago? Like this is pretty cool. So
Great. The next one is this, but we can skip it.
Hey, nice. I like how you put that one back up on the screen there. Thank you. I appreciate that.
Yeah, so the next one is we made Cypress end-to-end tests for all our components, example, date picker, etc. What would be our incentive to also add component testing along? Did we make a mistake investing time in end-to-end? And
yeah, that's a good question. So I would say definitely no. Like end-to-end tests are like the most valuable tests, because if your components work, like you want to make sure like users that interact with your website, like they have the experience you expect, right? So end-to-end test validates those things. Component testing, in my opinion, is most valuable when you're building new components. So when you're building a new component, you don't have to like add it in your website somewhere and then like navigate to that place, or like, scroll to where that is or whatever. Like you just get that component right there. So as you're building the component, you get like quick feedback, so you can see how it looks, how it interacts. And then like when you're done, you add a couple of tests, and like you like also get that as well. So I would say it wouldn't be hard to change some of those tests to component tests, because it's the same API, and it may speed up your test a bit, because mounting is much quicker than like visiting a URL that loads all of the assets it needs for the whole like website or page or something like that. So it could make sense to swap some of those out, but I would definitely say it's not an investment that was like, had no ROI. I think it's definitely a good investment.
Delete your end-to-end test. No. Just kidding.
yeah.
For the record.
Yeah, the next one is by Milutin. It's similar basically. So if we choose Cypress end-to-end test, does it mean we should reduce work on writing classical unit tests?
I would say not like by a principle, but I would say the effects of doing it, you will find a lot less like unit tests, because I used to like always write it felt like useless, like not very valuable unit tests and components, where it's like now all this, you don't really need to write unit tests of any component anymore. You could just like use component testing, and then the things you would still maybe want to test is like if there's like services, or like what my favorite thing is still test like NgRx selectors, like things like that are like business logic that have you want to make sure they're a very like a pure function. Anything like a pure function, you're still going to want to write unit tests for. But I think the sort of side effect of using component testing for your components is you'll eliminate a lot of unit tests that are probably not really providing the value you really think they were to begin with. So
yeah, if I could jump in here, I think what the Cypress unit test really fits into like that integration test area, where you may be bringing in like multiple things into a component, and you don't want to like have to mock out. You want to make sure that it's like that step above the unit test, where you're actually using some of the things inside of there, and you can still like provide that integration there without, like I said, having to mock out all the things and then run a test that only runs in isolation, and you don't know what it actually runs like.
Yeah, it is almost like replacing integration tests as much as anything, but it's not like the way we think of a traditional integration test. So yeah, so I don't like to use the word, but people get confused because they think of the pyramid like, where does it fit?
Yeah.
Yeah, and the next one is, what about mounting with injected dependencies such as services, stores, and other painful stuff?
Sure. So Cypress, it mounts using, it wraps on top of the test bed. So it uses Angular's, dependency magic, to do all those things. So you can just add a provider. You can you can basically pass in a test double for service, things like that. But yeah, so it gives you a lot of the magic you normally get with Angular, because it uses Angular on top of it. It just takes like the painful parts of like using JS DOM, and instead we put it like actually on a browser, and then you just use Cypress from that point. So
They're really trying to get into the magic. They want they just want to
yeah,
drop a drop a
exactly,
component in there and have it do everything.
pretty much.
Okay, and yeah, it seems there are no more questions in the chat, so we can end up for today. Thanks everyone for joining, and see you soon with more interesting topics. Bye bye.
Thanks. See ya.